I'm Lynn Bondurant at NASA's Lewis Research Center in Cleveland, Ohio. I'm hosting this program, Gemini Science. It's part of the series called Life in the Universe. During these programs, we're looking at how man learned to travel in space and how he's looking for extraterrestrial life, among other things. During our last program, we saw that Project Mercury was a first step in our goal to reach the moon. The Gemini project, the subject of this program, was the second step toward landing men on the moon. Gemini is a zodiacal constellation of the twins Castor and Pollux. And for the United States, during the Gemini project, 2 astronauts rode in the Gemini craft. Remember, only one spaceman could ride in the Mercury craft that preceded Gemini. The highlight of Gemini was learning to link up 2 spacecraft in space called rendezvous and docking. A second highlight was learning to walk in space. Of course, intense training of the astronauts continued in preparation for mankind's first trip to the moon. Now let's see a clip from a film called Legacy of Gemini, which shows astronaut training, Gemini craft flying in Earth orbit, as well as Gemini craft flying in formation and the photos of Earth.
On Gemini, training began on Earth and in the atmosphere. This specially designed airplane was flown hundreds of times on parabolic sweeps into the sky to provide the Gemini astronauts with brief periods of weightlessness. Here, seconds at a time, the difficulties of living in space were rehearsed. Working under zero gravity, the Gemini astronauts gained experience with the equipment and techniques they would soon take into space. It took hours of training under these rigorous conditions to develop the confidence needed for operating in the space environment. In the Gemini mission simulator, they flew entire missions without leaving the ground. Here, they learned to react quickly and correctly to problems fed to them through computers. The Gemini astronauts exposed themselves to the stresses of the space environment. They trained for emergencies, learning how to react if things did not go exactly according to plan. Parachute training, in case they were forced to eject from their spacecraft. Water survival for landings in the ocean. Survival in desert and jungle. But ultimately, there was no substitute for being there. Gemini took the men and the tools and the problems into orbit. In the 18 months between March 1965 and November 1966, 10 manned missions were launched from Cape Kennedy. 16 astronauts journeyed to their spacecraft on Launch Pad 19. Virgil Grissom and John Young were first. Then James McDivitt and Edward White, L. Gordon Cooper and Charles Conrad, Frank Borman and James Lovell, Walter Schirra, Thomas Stafford, Neil Armstrong, David Scott, Eugene Cernan and Michael Collins, Richard Gordon, Edwin Aldrin. 4 of the Gemini astronauts made the trip twice. Together, these men helped thrust the United States into a new era of exploration. Space is infinite. It yields slowly to exploration. In their voyages into this environment, the Gemini astronauts logged more than 1,940 man-hours of flight. Hurtling through space at 5 miles a second, they circled the Earth 600 times. In their 40 Earth days in space, They witnessed, as few men have, hundreds of sunsets on the changing horizons of our planet. Sweeping over continents in a matter of minutes, they gained a new perspective of Earth. For Gemini, equipment and techniques were developed that enabled astronauts for the first time to maneuver their spacecraft, to change their orbit, to accelerate to new heights. The first Gemini maneuvers were basic, flying formation with the spent second stage of the Titan II rocket. Then a more difficult step, rendezvous, finding and approaching another craft in space.
Okay, Gemini 6, ready to take copy. Okay, P8, 063500. Pass at Hawaii, Rev 4.
The first target for rendezvous was another manned spacecraft. Gemini 6 approached within 1 foot of Gemini 7. Rendezvous, a major landmark in the history of manned flight. On 4 of the Gemini missions, the rendezvous target was the Agena space vehicle. During the program, the Gemini astronauts located and docked with the Agenas 9 times, developing experience and confidence in this important maneuver. This experience is vital to the lunar mission, for the Apollo astronauts will dock twice on their journey from the Earth to the Moon and back. From their vantage point in space, the astronauts had a spectacular view of our planet. Although flight experience was the primary objective of Gemini, the program offered a unique space laboratory to science, medicine, and technology. More than 50 experiments were carried on the Gemini spacecraft. Many were repeated on several flights. One experiment was photography of the Earth. Vast areas never seen by man in their entirety were studied. More than 2,000 photographs were taken from space during the Gemini program. These pictures are being used to correct maps and to provide oceanographers, geologists, and geographers with new information about the Earth. Gemini astronauts also used their cameras to photograph cloud patterns and other atmospheric phenomena. This work supplemented information obtained from unmanned weather satellites. Hundreds of high-resolution photographs were made to provide new knowledge about the weather of the world. The astronomical sciences also benefited from Gemini, for the orbiting spacecraft enabled scientists to send instruments far above the blanket of atmosphere, which filters and obscures a variety of phenomena. On Gemini 12, an eclipse of the sun was photographed for the first time from space. results of scientific research conducted on Gemini have been made available to the world, not only helping to advance man's knowledge, but promoting a greater measure of understanding among nations. 3 of the manned Gemini missions were flown to investigate the problems of long-duration spaceflight. Gemini 4 was a 4-day mission. Gemini 5, 8 days. On Gemini 7, astronauts Lovell and Borman spent 2 weightless weeks in space. These flights confirmed the endurance of man and his new spacecraft systems. They showed that an astronaut can live in space longer than is required for a round trip to the moon, and thus paved the way for Project Apollo.
Spacewalks, or extravehicular activity, or EVA in space talk, was an integral part of the Gemini project. Now we'll see astronaut Ed White making America's first spacewalk. That EVA set the stage for man to begin to work in space.
Perhaps the most spectacular experiment of the Gemini program was extravehicular activity. Astronaut Ed White made the first American walk in space. Spurts of gas from White's handheld maneuvering device thrust him in the desired direction.
Are you ready, Captain? That's right, Captain.
The floating object in the foreground is the astronaut's overglove, left behind in the spacecraft.
I've exhausted the fuel now, but I was able to maneuver myself outside the spacecraft back. Maneuvered right up back on the top of the adapter. Took the bus Jim, came back into his view. The only thing I wish is I had more. This is the greatest experience it's just tremendous.
In contrast to Ed White's successful 20-minute walk in space, the next 3 men to venture outside their spacecraft encountered unexpected difficulties. Although some useful work was accomplished, including on one mission, the historic retrieval of a scientific experiment left behind on an earlier flight, workloads were higher than anticipated. The astronauts had trouble stabilizing themselves outside the spacecraft. All 3 walks had to be terminated early. So another more careful and more tightly controlled test was prepared for Gemini 12, the last flight in the program. Prior to this flight, astronaut Aldrin trained intensively underwater, pacing himself for his work in space.
Okay, good. All right, let me open it.
The tasks assigned to him were designed to compare the difficulty of working in a weightless environment with work under normal gravity. On Gemini 12, the problem of excess workload was overcome by frequent rest periods and the use of improved body positioning restraints, such as waist tethers, handholds, and foot restraints.
Sounds good. I'm going to take the Velcro off.
Extravehicular activity has important applications to the lunar mission. Apollo astronauts will leave their vehicle and install scientific equipment and collect samples on the surface of the moon. This requires experience working in pressure suits and performing tasks in the near vacuum of space. Gemini provided more than 12 hours of experience in extravehicular activity. The training, the caution, the slow accumulation of facts paid off. Man can work in space.
During Gemini, longer missions were possible than during the earlier Mercury project. Now more time in orbit permitted the 2 Gemini astronauts aboard each flight to observe the Earth and conduct experiments aboard their spacecraft. Life science experiments were among the investigations conducted. Much planning had to be done before the experiments were sent into space. Let's look at a film explaining those experiments.
The most interesting and perhaps the most significant factor of the space environment to the life scientist is weightlessness. Investigation of this unique phenomenon and its effect on the living organism will contribute to the development of a new concept, that of gravitation biology. Experiments are needed to determine these effects on cellular processes, vital activity, development and growth of living organisms.
At the NASA Ames Research Center, 2 related experiments are being carried out as part of the Gemini science program.
The experiments that we're discussing here are a preliminary and very simple attempt to ask a scientific question concerning the gravitational requirement of contemporary cells. The cell, the fundamental biological unit, has, during the course of biological evolution, seen nothing but a 1G, if you will, a 1 gravitational field environment. What we want to know is, first of all, is this 1G required for cells to perform normally, for them to divide and metabolize normally? And if so, how do these cells sense their gravitational field? What's the mechanism? We're using standard laboratory research tools in that we're using cells that are commonly used by biologists in many laboratories throughout the world. We're using the egg of the sea urchin and the egg of the frog. The reason for using these 2 eggs is that, first of all, there's a large backlog of information concerning the chemistry and biology of both of these eggs. They're easily available and easy to handle. The material, the eggs themselves of the frog, are being inserted in a piece of hardware that looks very much like this. The actual flight item will have an electronic package mounted on the outside, which maintains the temperature inside the chamber. The handles here are for use by the astronauts for actuating the injection of a fixative into the experimental chamber. The frog egg, which senses a gravitational field the minute it's fertilized, will be inserted in plastic cylinders inside the package. What the astronaut is called on to do is, during the 0G phase of the flight, at the time when the cells, the frog eggs, are dividing for the first time, he'll turn the handle. This injects the fixative, kills some of the eggs at the time of first cleavage. Before re-entry, depending on how long the flight is, he'll actuate the second handle, which will kill some of the eggs which have been allowed to develop much further. As a matter of fact, they're practically tadpoles if the flight has gone far enough and if the cells have been able to divide normally. So we get a look then at a fairly broad spectrum of cellular activity in the frog egg. Now, we've also made attempts, and we'll continue to make attempts, to do a similar experiment using the sea urchin egg, using this type of hardware. Now, the sea urchin egg doesn't seem to care what its gravitational field is. It doesn't know whether one end is up and the other end is down the way the frog egg does. It seems to respond differently. So we really have 2 different types of cells which we think may respond in different ways. What this sort of an experiment will lead to, we can't really say. We expect that if we get a positive indication, positive results from this kind of an experiment, we'll do a considerably more complex experiment in later flights, perhaps in the Apollo program.
Of serious consequence to the manned spaceflight program and of special interest to the space scientist is the possible effect of radiation on the living organism, especially during weightlessness. One of the Gemini Science Program's experiments is to investigate the synergistic effect of radiation and zero gravity on human white blood cells. This experiment is being prepared at the Oak Ridge National Laboratory, Tennessee.
Our experiment was designed to test whether there are, as has been suggested, unusual biological effects of radiation encountered during the course of a space flight. Human blood samples were exposed to known doses of radiation during the Gemini 3 mission. Simultaneous in-flight and ground control experiments were performed. Because of the perishable nature of the living blood cells, the device had to be loaded, assembled, welded, tested, and installed aboard these spacecraft immediately before flight. This is a model of the device fabricated and designed by the Fidge Y12 plant to carry out the irradiation. The sterile blood samples are located in these plastic blood sample chambers in an hermetically sealed aluminum case. Some 50 minutes after the beginning of the flight, the pilot operated the handle, thus moving the blood sample holders in between the phosphorus-32 radiation sources. 20 minutes later, the pilot reversed his operation, thus withdrawing the blood samples from the radiation source array. After recovery, the boxes were cut open, the blood samples removed and put in culture. Some 66 hours later, the cultures were fixed and chromosome preparations were made. Upon return to Oak Ridge, the leukocyte chromosome preparations were scored. Some 200,000 chromosomes were analyzed. Two classes of aberrations were observed. Single break aberrations produce only a single pair of fragments. Multiple break aberrations, on the other hand, in addition to the fragments, produce new chromosome forms, such as this dicentric. While there was no difference in the yields of aberrations of the multiple break type between the ground control and the flight experiments, there was a statistically significant difference between the yields of single break aberrations. Thus, it appears that there is no unusually large hazard from radiation associated with space flights. On the other hand, the experiment shows that there is an effect, one that is interesting to radiobiologists. For this reason, we plan to repeat and extend our experiments on later manned spaceflight missions.
One of our experiments has been designed to answer a question which is quite important to manned spaceflight, namely, what exactly can an astronaut see from an orbiting spacecraft? First, we taught the astronauts to measure their own visual acuity during flight by means of a specially designed vision tester, which we built for the purposes of the experiment. Their training also included flights in conventional aircraft, designed to give them familiarity with a special pattern which we laid out on the ground. This pattern was composed of white rectangles, randomly oriented and laid out on plowed ground. The astronauts were required to report by radio on the orientation of the various rectangles. During the actual Gemini spaceflight, the experiment is done in precisely the same way. The flight plan calls for the astronauts to observe each day, to look down from space on the pattern on the ground, and also each day to test their visual acuity with the onboard vision tester. We have some data from the GT5 mission and some preliminary conclusions from those data. This figure shows
that the visual performance of the astronaut before the mission was essentially identical with his performance throughout the mission. And this figure has a solid curve which represents the visual performance of the astronaut throughout the many experiments that were made before flight. If performance in space was the same as it was before the flight, then the threshold measurement obtained by his out-of-the-window observation of the ground patterns should fall on that line. And these 2 points obtained during the GT5 mission indicate just that.
The life science experiments showed that neither orbital spaceflight nor any of the stresses connected with it produced significant, unpredicted genetic damage. Also, we learned that a gravitational field is not necessary for frog eggs to divide normally. There was inconclusive data for the sea urchin egg fertilization experiment. What kinds of things did we learn from Gemini? Let's see a film clip to explain.
Of first importance is the fact that Gemini sent more men into space and kept them there longer. People in other nations not only witnessed Gemini as it happened, but also helped accomplish the program's objectives, showing again the necessity for international cooperation in the peaceful exploration of space. Gemini also leaves as its legacy a greatly expanded science and technology, proof that government, industry, and the scientific community can work together to translate man's boldest dreams into action. In the front ranks of the bearers of Gemini's legacy are the astronauts themselves. These veterans are now ready to face the challenge of Apollo.
The Apollo project was the next step in exploration of the universe, landing men on the moon. Please join us during our next program in this series when we focus in on efforts to find out if there were life forms in the lunar rocks and soil brought back to Earth from the moon. This is Lynn Bondurant saying goodbye from NASA's Lewis Research Center in Cleveland, Ohio. I'm Lynn Bondurant at NASA's Lewis Research Center in Cleveland, Ohio. I'm hosting this program, Gemini Science. It's part of the series called Life in the Universe. During these programs, we're looking at how man learned to travel in space and how he's looking for extraterrestrial life, among other things. During our last program, walk in space. Of course, intense training of the astronauts continued in preparation for mankind's first trip to the moon. Now let's see a clip from a film called Legacy of Gemini, which shows astronaut training, Gemini craft flying in Earth orbit, as well as Gemini craft flying in formation and the photos of Earth.
On Gemini, training began on Earth and in the atmosphere. This specially designed airplane was flown hundreds of times on parabolic sweeps into the sky to provide the Gemini astronauts with brief periods of weightlessness. Here, seconds at a time, the difficulties of living in space were rehearsed. Working under zero gravity, the Gemini astronauts gained experience with the equipment and techniques they would soon take into space. It took hours of training under these rigorous conditions to develop the confidence needed for operating in the space environment.
We saw that Project Mercury was a first step in our goal to reach the moon. The Gemini project, the subject of this program, was the second step toward landing men on the moon. Gemini is a zodiacal constellation of the twins Castor and Pollux. And for the United States, during the Gemini project, 2 astronauts rode in the Gemini craft. Remember, only one spaceman could ride in the Mercury craft that preceded Gemini. The highlight of Gemini was learning to link up 2 spacecraft in space called rendezvous and docking. A second highlight was learning to